In this video, we're going to cover how to add rational expressions. Hopefully by this time we've already kind of gone over how to add regular fractions. If not, here's a quick reminder. Let's say we have like something like this, 3 over 4 plus 2 over, we'll say 3, just for the sake of similarity. In this case, we cannot add them right away because we have what's called a different denominator, so 4 and 3 are not the same. So what we do is we find a common multiple. We can call this the LCM, least common multiple, that both 4 and 3 go into, so we can make these with the same denominator. So in this case, I know that 4 and 3 both go into 12. So I'm going to go ahead and change them to fractions in terms of 12. So what I do is I say, well, I know 4 times 3 is 12. But since I multiply the bottom, I have to multiply the top as well. And on this side, I know that 3 times 4 is 12. And then same thing here, I have to multiply the top. So doing this multiplication gives me 3 times 3 is 9, 3 times 4 is 12, plus 2 times 4 is 8, and again 3 times 4 is 12. So now this has the same denominator, so we can go ahead and add. So in this case, this would just be 9 plus 8 is 17 over 12. And if you can reduce, you reduce. If not, then there's your answer. Okay, so same concept, but now we're going to throw in those lovely letters that we all love so much. So over here, I'm going to go ahead and find the LCM first. And just like my previous little example here, I see that I have a 4 and a 3, so there's probably going to be a 12 involved because again, 3 times 4 is 12, and both of these numbers don't go into anything smaller. And there's an x as well, so I'm just going to include the x. So like my little example over here, I'm going to multiply this side by 3 and this side by 4. Doing so gives me 3 times 8. Let's change the color. 3 times 8 is 24. 3 times 4x is 12x. Bring down the plus. 3 times 4 is 12. And again, 3 times 4 is 12. And bring down the x. So now you can see that both denominators are the same. When we have same denominators, we can go ahead and add the top. So this is going to give us 24 plus 12 is 36 over 12x. And if I can simplify the fraction, I do. In this case, you can see that 36 over 12 is divisible by 12. So 36 divided by 12 is going to be 3. 12 divided by 12 is just 1. Bring that x. And of course, we don't usually have to write that 1 if we have a term next to it. What happened there? A term next to it. So we can just go ahead and erase that. Okay? And so this would be our answer, 3 over x in this case. Keep in mind, these are not easy. So if you need to go back and review the problem, that is perfectly fine. Okay? Go ahead and look at another one. So now we have 1 over 5x squared plus 8 over 5x. We're going to do the same thing and find the least common multiple. In this case, you can see that both of them have a 5, so I'm going to go ahead and leave the 5 there. So if they have something in common, you pretty much leave it there. Okay? And now this one has an x squared and this one has an x. So in this case, we have to put the bigger one because there's no way that I'm going to get an x squared out of just an x, if that makes any sense. So another way to think about this is 5 times x for this one. So this one is missing an x. We want them to be the same. Okay, so my LCM is going to be 5x squared. I'll go ahead and kind of rewrite this over here. So I have 1 over 5x squared. That one already has it, so we don't have to do anything to this one, plus 8 over 5x. So what can I do to this one, the second one, to make it look like this one? Well, I just have to multiply by an x. So times x. And of course, whatever I do to the bottom, I have to do to the top. So there we go. So this leaves me with 1 over 5x squared, and I'm just copying this one, plus 8 times x is 8x, over 5x times x is 5x squared. And now that I have same denominators, I can go ahead and add the numerators. So 1 plus 8x, I'm going to go ahead and put the 8x first, just because that's convention, all over 5x squared. And in this case, we really can't do anything to the top or the bottom, so this is just our answer right here. Okay. 2 more problems. Here we have 6 over 9x and 2 over 8x. So I'm going to go ahead and do the same thing, find the least common multiple. In this case, we have 9 and 8. So if you think about the multiples of 9, we have 9, 18, 27, 36, and it just keeps going on. And 8 doesn't really fall into any of them. So what some people do is they just kind of multiply these two numbers, and that works. Most of the time, you'll just have to kind of simplify at the end, okay? So 9 times 8 is 72. And of course, we have an x, so we have to leave that there. Just like before, 9 times what is 72? Well, 9 times 8. So I'm going to multiply by 8. Same thing up here, by 8. And on this side, I know that 8 times 9 is 72. So I'm going to multiply this side by 9. And so we have 8 times 6 is 48 over 72x. Remember, the denominator should be whatever I have over here, okay? Plus 2 times 9 is 18. 8 times 9 is 72x again. So we have common denominators. I can go ahead and add the numerator part. 48 plus 18, what would that give us? Let's see. It's going to be 66, I believe. Yeah. Okay, so we have 66 over 72x. And in this case, we can probably divide by 2 at least to simplify it. So you want to make sure that your fraction is simplified. So let's try dividing by 2. Let me get a different color for that. I mean, worst case scenario, you don't simplify it and you still have the correct answer. It's just not simplified. Okay, so 66 divided by 2 is going to give me 33. And 72 divided by 2 is going to give me 36. And we have to bring that x over. And 33 can be divided, let's see, oh, we could probably go more. So 33 divided by 3 would be 11. If I divide this one by 3, that would be 12. Okay, so now at this point, we can finally stop. And notice that since I did have to divide 2 times, so this is kind of an example of what happens if you do not find the biggest number that goes into both of them. In this case, if I had divided by 6, so if I had divided by 6, I would have gotten here right away. But it's even if you don't, it's okay. So see, I still ended up with the correct answer. I just had to do an extra step. And that's okay too. I know a lot of us struggle with our multiplications, so just kind of wanted to show you one where this happens. Go ahead and look at the final example. This is a kind of a tricky one because it has a lot of numbers that are the same and it has x's and they're just kind of in the wrong order. So this is a special case that I'm going to show you because it does tend to pop up a lot. In this special case, we have x minus 5 and 5 minus x. I want you to circle this one. And we're going to work with this one on the side. 5, let me do that. Okay, so we have 5 minus x. I've told you in the past that we can always divide by a negative 1. So we're going to do that. If I divide this by negative 1, so I'm going to factor it, okay, I would get negative 1 on the outside, and 5 over negative 1 is negative 5. Negative x over negative 1 is positive x. This, what I just did, is what we've been doing for GCD factoring. We've done quite a bit of that, so This right here is what is GCD factoring. Okay, now I'm going to rearrange this. So I'm going to leave the -1 out there, and I'm just going to flip these two things. So x minus 5, just because I want the x first and I want the 5 at the end. So doing this gives me this new thing right here, -1 times all this. So I'm going to go ahead and rewrite this expression like that. So I have 5 over x minus 5, and I'm just rewriting, okay, plus x over this whole thing right here. So -1 x minus 5. Okay, so doing this, we can see that both of them now have that x minus 5 that we've been wanting, but this one has a -1. So my LCM for this one would be -1 x minus 5. So all I have to do is multiply this side by -1. Doing so, -1 times 5 is -5 over, I'm just going to leave that how I have the other one, plus, that one stays the same, leave the bottom. So the beauty with this is that once you find that LCM, the denominator pretty much stays the same. Okay, we're multiplying there. So from here, since they both have the same denominator now, I can go ahead and add the top. So I'm going to have -5 plus x all over this denominator. So -1 times x minus 5. And if you notice, we have a similar situation right here where we can probably move this around. So I'm going to go ahead and do the same thing I did right now. And I'm going to rearrange. So I have x minus 5. Remember, this right here is this one, and the x is this one. So all I did is I just switched them. Okay, so x minus 5 over -1 times x minus 5. And doing that, you can see that we have this term and this term the same. And we have already seen this in the past. When this happens, these cancel out to 1. So my final answer, there's a 1 left on top. There's that -1 on the bottom. We divide, and we end up with just -1. Again, if this one was a little too much, you're welcome to go back and kind of pause, look at the steps. You can always come in and ask me as well. Once again, this is a difficult topic, so if you don't get it the first time, there's absolutely no judgment. Okay, this takes some practice to get these. That's it for this video.